Today we're going to discuss irrational solutions when we're solving quadratics. So rational numbers, just a few reminders of some vocabulary, are numbers with a decimal that either ends or repeats. Think about numbers like 1/3. So that's a 0.3333, and that number repeats forever, never ending. Or 0.25. Okay, that decimal ends after the 5. 8, we could write it as 8.0. That's an ending decimal. A number like negative 0.275, again, ends there. Or anything else like those that either end or repeat. Those are rational numbers. Then there are irrational numbers, and these are numbers with a decimal that neither end nor repeat. So these are going to be our numbers like pi. Remember, pi is a decimal that never repeats, never ends. But so are numbers like the square root of 2. Taking the square root of a number that's not a square, those tend to be numbers that don't repeat or end. The square root of 5, the square root of 20, any number that's not a square. Also the negative square root of 17, or any other number, 20, 21, any number that's not a square. Those are all going to be numbers that don't end or have a repeating decimal. And it's important to know that know the difference between those two numbers, a rational number and an irrational number. So there's also a couple other words. Radical expression. This is something that you may have seen before, but a radical expression is just an expression containing a radical symbol. And if you don't remember, the radical symbol is the square root symbol or the cube root symbol. It's that symbol right there. We understand it to be the square root symbol unless there's a number outside of this, like a 3 or a 4, another, they call it an index, that lets us know that it's a cube root or something along those lines. But it's a radical symbol. Now, the radicand is the other term that you need to know, and that is the expression under the radical symbol. So anything that's under that symbol is known as the radicand. All right, so we've been talking about solving quadratics, and we've talked about the several different methods for doing that. Graphing, we know that there's to factor them, or we can do the quadratic formula. So we know that a line doesn't always have to pass through that whole number like we've been getting in the past. Sometimes we end up with an answer that is irrational. It's an answer that doesn't simplify perfectly like we want it to, and so that's where we're going to talk today about irrational solutions. So when you're solving quadratics using the quadratic formula, what do we do when the number under the radical symbol isn't a square? So when we come up with a number in that portion of the quadratic formula, what do we do when that's not a square and we need to simplify our answer? And so what happens there is this is known as an irrational solution. And if it occurs, we just need to simplify the solution into its simplest radical form. And we're going to simplify that into its simplest radical form. All right, and so when we simplify a radical expression, what we want to do is pull out any squares that are factors of the radicand We're going to pull those out so that we have the simplest number under the radical symbol, and everything else has been pulled outside of that so that we can simplify our solution to its simplest form. Okay, and so when I'm talking about pulling a square out, this is what I mean. So here's an example. If you have the square root of 48, and we try to take the square root of 48, it's not a square. The square root of 49 is, but not the square root of 48. And if we put that in our calculator, we get a number with a decimal that never ends. It doesn't repeat, and it's just an irrational solution. So what we can do is we can start looking for factors of 48 that might be squares. So for example, 48, the factors of 48, we could do 4 and 12. 4 times 12 is 48. So here what I could do is say, well, 4 is a square, so let me pull that out. So the square root of 4 is 2. I'm going to pull it outside of the radical symbol and leave the 12 under. And notice that with my calculator, I just want to show you a couple of things. We want to keep these equal, so we're not changing the value of our answer. We're just simplifying it another way. So if I take the square root of 48, this is the irrational solution that I get. And then if I also take 2 times the square root of 12, I get the exact same numbers. What I've done here is just pulled a square out of this and left the rest of it still under the radicand, okay? Or the radical symbol, sorry. All right, so what we did here is we pulled out the square root of 4, which is 2, and we left it to be multiplied by the radical, okay? So it's out here outside of the radical symbol now. So the factors of 12, we now need to check to make sure that there's not any other squares involved. So I'm going to look down here. I have 2 times the square root of 12, which is where I just left off. And now I want, what are some factors of 12? Well, there's 1 and 12, 2 and 6, 4 and 3. 4 is another square, so I could do 4 and 3 here. So 2 times the square root of 4 times 3. Now, I can pull that 4 out as well. So if I take the square root of 4 and pull it out, I now have this 2 that was already here times another 2 that I just pulled out, and I'm left with just this 3 on the inside. And so that's what I've done here. Pull out the square root of 4 again and multiply that 2 by the 2 that was already there. And so this 2 times 2 can be simplified. So when I go to look at this, the simplest radical form of the square root of 48 is written as 2 times 2, which is 4, multiplied by the square root of 3. And I can check that again. So notice here on my calculator, I have the square root of 48, I have 2 times the square root of 12, and then let's try 4 times the square root of 3, and they should all be exactly the same number. So all we've done is simplify it into another format that's just a little bit easier to work with and allows me to simplify further later on if needed. So again, I took the square root of 48 and I factored that to 4 and 12, and I pulled the 2 out. I took the 4 and took the square root of that as 2 and pulled it out to the outside of the radical symbol, left the 12 inside. Now 12 was still factorable, so I went down and I factored it to a 4 and a 3. So then I took that 4 again to the square root of that and pulled it out as a 2, and so that 2 coupled with the 2 I already had became 4 times the square root of the 3, what was left over, okay? And it gets easier the more that you practice this. But you just need to know those factors and work through looking for those squares. So sometimes there are no squares to pull out of the radicand, and if that's the case, the solution is most likely already in its simplest radical form, and that's okay. So just know that you don't always have a square that you can pull out. Sometimes it happens that there's not one. Okay, so let's kind of do an example here where we're going to factor. Or not factor, we're going to solve this quadratic. So our answer is already in standard form, it's already simplified, it's already set equal to 0. Let's do a quick discriminant test to make sure that we have solutions for this. So remember that A is 4, B is -4, and C is -11 here. Those are just my coefficients here. and my constant, and I'm going to plug that into the discriminant formula. So I have I have b squared, so negative 4 squared minus 4 times a, which is 4, times c, which is negative 11. And then I can simplify that in my calculator, and I get 192. Any number that I get here that's greater than 0 tells me that I have 2 solutions. So I know that I'm going to have some solutions here. So let's go ahead and plug these into my quadratic formula. So quadratic formula, I have a negative b, and in this case b is a negative 4, plus or minus the square root of that b squared, negative 4 squared, minus 4 times a, which is 4, times c, which is negative 11, divided by 2 times a, in this case, is 4. Okay, so when I go to simplify this, what I end up with is 4 plus or minus the square root of 192. Notice I already did all of this under the radical symbol, this radicand. I'd already simplified it up here as my discriminant value, so it was 192. Well, if I do the square root of 192 here, I end up with an irrational solution. So I've got to come up with some factors of 192 that I can potentially take out of this. So let's just kind of start pulling out some numbers and seeing what we can do here. So 192 could be broken down into, let's see, I could divide it by 4, and I would get 4 and 48. So 4 would be a square that I could take out. So I can pull that one out. And then I have 48 could also be broken down into 4 and 12. So that would also work. And then 12 could be broken into 4 and 3. So ultimately I have a 4, a 4, a 4, and a 3. And so let's just double check that that equals 192. So 4 times 4 times 4 times 3 altogether does equal 192. So those are the numbers that I'm going to factor this 192 into. So I have, let's see, the square root of 4 times 4 times 4 times 3, okay? And then I'm going to take the square root of 4, that's 2, and I'm going to take the square root of 4, and that's 2, and I'm going to take the square root of this 4, and that's 2, and then I'm going to leave my 3 inside. So what I end up with here is 2 times 2, which is 4, times 2, which is 8, times the square root of 3. And I just want to double check that this works until I get comfortable with it. And so 8 times the square root of 3 gives me the same as the square root of 192. So perfect. I've done this simplified correctly. Okay, so that leaves me with the answer x is equal to, and I'm going to plug this back in up here where I had the square root of 192. So x is equal to 4 plus or minus 8 times the square root of 3 divided by 8. All right. Now, one other thing to look at, if both of your numbers outside of the radical symbol in the numerator, so the 4 and the 8 here, can be simplified along with the denominator. For example, I can take the 4 and the 8 and the 8 and the 8, and I can simplify those. Then I can simplify this a bit further. And in this case, I can, because they're all divisible by 2. So they're also all divisible by 4. So I'm going to take out my greatest common factor there. So divide 4 by 4, I have 1. I divide 8 by 4, and I have 2. And I divide 8 by 4, and I get 2. So when I rewrite this, my final answer is really going to be as simple as 1 plus or minus 2 times the square root of 3 divided by 2. And that's the simplest radical form on this. And I can check myself all along the way, because when I have this solution, I could type all of this in very carefully into my calculator, and I could check all of this into my calculator, and I could type all of this into my calculator, and all along the way I'm going to have the exact same answer. This is just written in the most precise and simplest form. I could write my answers out as decimals with 2 to 3 decimal places if that's what you're asked to do. But if you're asked to write it in the simplest radical form, this is the way that we simplify those radical irrational solutions.